today. So our speaker, Professor Surya Prakash, has already joined. So before start of the session, I would like to introduce the speaker to the audience. So, Dr. Surya Prakash is presently working as professor and head Geometeorological Risks Management Division and also head of the CBRN, Industrial and Cyber DRR Division, team leader for World Center of Excellence on Landslides, Disaster Reduction, and faculty in charge of 8 specialized centers, that is Center on Early Warning and Communication, Safe Hill Area Development, Coastal Disaster Risk Reduction and Resilience, Emergency Operations Center, Power Monitoring Cell, CBRN, Industrial DRR and Cyber DRR. He is team leader of the international project IPL 233 and IPL 172 under international program on landslides at National Institute of Disaster Management, Ministry of Home Affairs, Government of India. He was team leader for NDMA joint team to study the recent Uttarakhand disaster 17th February 2021 to suggest measures for disaster risk reduction and resilience. He was a member of IMCT Interministerial Central Team during the pandemics. He is also a nodal faculty for 9 central ministries for coordinating disaster management activities, including Ministry of Petroleum and Natural Gas, Coal, New and Renewable Energy, Communication, Mines, Shipping, Labor and Employment, DGMS, Parliamentary Affairs, and North Eastern States. Formerly, he was head of the Knowledge Management and Communication Division and also former head of the Hydrometeorological Risk Management Division, former administrator NIDM, GFDRR, World Bank, online courses and program coordinator for web-based self-study program at NIDM. He was coordinator for the Indo-Japanese Action Plan on landslides and disaster management as part of the security declaration between Government of India and Japan, signed by the Prime Ministers of both the countries. He was member of the Indian delegation at the Third World Conference on Disaster Risk Reduction, 14 to 18th March 2015 at Sendai, Japan. He has organized more than 300 national and international trainings, webinars, workshops, and conferences related to different aspects of disaster management. He has been a member of the core group, task forces, and working groups for development of national guidelines and strategies on disaster management. He has been recognized as a qualified professional RQP geologist by Indian Bureau of Mines, a licensed HAM by Department of Telecom, and its member of the International Consortium on Landslides, Japan. He is national coordinator for IAPG, International Association for Promoting Geoethics, Italy, in India. He has been the founder of chairman of the Community-Based Disaster Risk Management Society in India. He has been a recipient of UGC's National Merit Scholarship and CSIR fellowships during his studies. He obtained doctoral degree, PhD, from IIT Roorkee and did specialized training on climate and geohazards risk management from University of Geneva, Switzerland. Seismic design and construction training from International Institute of Earthquake Engineering and Seismology, IIZIS.
Sir, I think it's enough. We can stop it here.
Sir,
Introduction.
Just a minute. Okay, sir. Is Macedonia. So disaster risk management and the insurance from Middle East Technical University, Ankara, Turkey. He was awarded academic fellowship by the World Bank Institute, Washington, and received various international grants and the Swiss Agency for Development Cooperation for Development and Cooperation, Berne, Royal Government of Netherlands, Japanese Landslide Society, National Taiwan University, etc. So with this, I would like to request Professor Surya Prakash to start his presentation.
Thank you. Am I audible?
Yes, sir.
Okay. And my PPT is visible in slideshow mode?
Yes, sir.
Okay. Then thank you, first of all, for providing me this opportunity to talk to you about landslide generation maps of India. So, since we have about 1.5 hours, so I'll just start directly with the topic. Since many of you may be from Odisha, so you may not have even witnessed any landslides if you have not visited the Himalayan terrains or the southern part of our country, which are Western Ghats or the northeastern part of the country. However, very recently, some of the landslides have been reported even from the state of Odisha. These are the superficial landslides, whereas there are many landslides which occur actually below the land, which are actually subterranean landslides, which may be the coastal landslides or the submarine landslides, which Odisha can experience, and that can also cause even a tsunami, like the one which happened on 26 December 2004. And further, there is a climate change going on, and this is changing our distribution of the precipitation, its intensity, and its onset of the season. And all these are actually contributing now to new phenomena or emerging threats and risks in the form of landslides and other disasters. I'm just showing you one of those examples which we recently experienced during this COVID period on 7th February 2021 in Uttarakhand state, Chamoli district, Joshimath block. I am showing you two pictures, one on the left hand side and one on the right hand side, before and after, of a hydropower project close to Reni village. Reni village is one of those villages where one of the famous environmentalist, Gora Devi, used to live. Gora Devi is famous for the Chipko Andolan, for the protection of the forests during the historical times. Many others landslides you must have heard in the media. For example, there was landslides in Chembur and Bikroli of Mumbai on 18th July 2021, where more than 30 people got killed in several of these incidents. Then there was a landslide in Batseri, in North District, on the roadside, where about 13 people were killed and a bridge had failed because of the landslide. And then Nainital area, you're knowing Nainital and Mussoorie are one of the big, famous places for tourism in Uttarakhand state. Kokar landslide from Kerala, which happened on 16th October, which also claimed 6 human lives. Then I'm showing one of those landslides which I had to go through. You all must be well aware about the June 2013 disaster in Kedarnath on 16th and 17th of June. Subsequent to that, I was there in Uttarakhand from 11th to 17th of June, and after my return from that place on 17th June, I was asked to go back to help the state, and I had to cross these landslides. I'm showing you a picture of one of those landslides which I crossed immediately after the Kedarnath disaster. And this is the scenario. The first photograph was taken at 11 a.m. and this photograph was taken at about 4:30 p.m. on the same day. Imagine the plight. I had to cross this road, driving my own vehicle by myself in this crisis situation. So if you're not well aware about these events, you know that so many people, they became victim of landslides and floods during 2013. Thousands of people got killed. And there are many such other instances where several of the houses, hundreds of houses, are at risk because of landsliding from a hilly area. And I'm showing you two photographs. The previous photograph was taken on 25th September 2003, and this is on 26th September, next day morning. So, and the previous was taken in the afternoon of the previous day. So you can see how big the landslides happen, and from such a height of about more than 500 meters, they can actually demolish anything that can come in their way. And these were the 3-4 hotels which were buried under these landslides. This again photo is taken just a day before they got buried under this landslide. And I personally used to stay in some of these hotels for my during my visits to this place. This is in Uttarkashi, Varna Hills in Uttarakhand state. And this was the state on the next day. You cannot even imagine the existence of those hotels on that roadside. Then Mizoram Aizawl, a CPTWD building fall down on other residential buildings, and about more than 30 people, they got killed. So there are several, and 18 children on 18th August 2010 between the age of 5 to 12 years in this school, which was a primary school, got killed because of a landslide. So I can tell you so many landslides in even high altitude desert area like Leh. More than around about 150 people, they got killed in August 2009 when a heavy precipitation took place in this high altitude desert area. The precipitation was more than the total annual rainfall of this area. Then another incident where 43 people got buried under the landslide, and they are buried alive. And this is the state. You can see when their body is getting recovered, parts of their body are cut off, and they cannot be easily recovered. Then the heritage structures like the railway line in Darjeeling area. So be it any part of our country, whether it is north, south, east or west, or the central India, everywhere we can find landslides. From Karnataka, Karwad area, you can see people are buried in the position as they were before the landslide happened. 19 people got killed in 2009. And their bodies are getting recovered. Kerala, 2018 floods, all of you may be well aware. So this is how you can see the different parts of the country and their impacts of the landslides and casualties. So looking into all the situations, our experts, they prepared hazard zonation maps. I will share that information with all of you, that how these works were done. For your kind information, it's the Geological Survey of India which has been assigned the role of nodal agency for the landslide disasters. So GSI, as per mandate given to it, has identified the total area under risk. And it was identified that about 4.2 lakh square kilometer of the country's area, territorial area, is affected by landslides of various degrees. It constitutes almost about 12.6% of the total land territory of our country. Then, this distribution of area is not equal in all the states. You can see many of the states which I have listed. Odisha just has about 0.01% of the land area under landslides. So compared to other states where almost more than 42% or almost more than 50% of the states area are affected by landslides. So that way, I would say Odisha is lucky to have least number of landslides in terms of the area under the landslides. Then what has been done for zonation studies, Geological Survey of India launched a national landslide susceptibility mapping program. And in order to do those landslide zonation mapping, a number of layers are to be prepared based on the attributes of the terrain and the morphological processes as well as the atmospheric processes to be considered along with the terrain factors. So all these terrain factors, drainage map, land use and land cover map, relief map, slope aspect map, and all such similar layers have been prepared and then clubbed together through a model which integrates all these data and identifies the hazard zones of various degrees. If you look into the total areas affected by landslides in each of these states or the region, and the area which has been mapped in 1:50,000 scale by Geological Survey of India, you can see that around 18 states and UTs within our country. In total, we have 36 states and UTs. So 50% of our states and UTs, they are affected by landslides. And about 158 districts, they are affected by landslides out of almost about 750 districts in the country. So 1/5 of the districts within the country, they are affected. And almost about 65,000 villages, they are affected by the occurrences of the landslides. So these landslide distributions, you can see the targets have been achieved for the zonation mapping scales by the Geological Survey of India for Northwestern Himalaya, Darjeeling, Sikkim Himalayas, Arunachal, Northeast, Western Ghats, and in total. So total target was about 4,34,795 square kilometer, while they have completed about the 3,99,664 square kilometer area. And these maps are actually showing the different zones in terms of low zone, hazard zone, moderate hazard zone, and high hazard zone. You can see that not only the national level zonation mapping, but also the state level mappings have been completed in several of the states. And you can see this on the one side, there is a map of Uttarakhand state. On the other side, we have a landslide susceptibility map of Karnataka and Goa. Now, these maps are also showing the distribution of the landslides and the important places which are affected by these landslides. If you look into the number of districts that have been affected and the degree of the susceptibility, then you can see that degree of susceptibility is quite variable. However, the number of districts with lesser susceptibility distribution under high hazard class are less compared to the number of districts under the very high or high susceptibility classes. So this distribution varies from 1 to 67. Then another important parameter for landslide zonation studies is the scale. The scale which I told you at the national level, we are often using 1:6 million scale. At the state levels, we have been using the 1:50,000 scale topo sheets. And at the town levels, the mapping is usually done in 1:10,000 scale. We can often call it as a meso scale. And when we talk about the 1:50,000 or more, it is called as macro scale. And if we go even to the site-specific studies in the scale of 1:1000 or 1:500 or 1:100 scale, then it is termed as a micro zonation studies. So one of those studies which have been done by Geological Survey of India in one of the places, the map is shown over here, how these maps are actually identify the specific landslides and the type of the failure along with the potential measures to stabilize those landslides. So you can see a table below where they have suggested the management advisories to the landslide areas which have been noticed under the mesoscale mapping. Other maps and advantages that you can generate process-specific landslide map. And landslide is a common word which actually encompasses at least 5 process groups, in which we include rock falls, topples, we include debris flows or flows, you can say. It can be debris flow or soil flow, or it can be rock flows. And also we cover slides. Slides can be translational landslides, wedge landslides, or rotational landslides. Depending on the type of material involved into it, they can be named as debris slides or rock slides or soil slides. And then we can have subsidences, and there are lateral spreads in the hilly terrain. So there are different types of landslides, processes which can be identified, and process-specific maps can also be generated. Here you are seeing some of the mesoscale maps where Geological Survey of India prepared maps based on rock slide susceptibility, rock fall, or debris slides, and combined slide susceptibilities. So this is how this is done. And the other thing which is important is their run out distance of a landslide and the nature of the slope, whether it is a natural slope or a cut slope. The structures at risk can be affected to different degrees. So these are parameters which are required by any disaster managers for reducing the risk and enhancing resilience against landslides. So in order to disseminate this information to the concerned stakeholders, Geological Survey of India actually started with a web portal called Bhukosh. In Bhukosh, they have actually provided the layers of these maps and the zonation maps, and as well as the landslide inventory data for the masses to access and utilize for their purposes. So you can see the information provided by the Geological Survey of India at this portal at present is about 6,519 landslide inventory, and also the landslide susceptibility maps. So all these informations one can access, and these can be utilized by the state disaster management authorities, the district disaster management authorities, and the national disaster management authorities. For the access, you have to actually register with their website and then download these informations. So accessibility is free, and this is how the main page for the login will appear, and then using your login and password, the different layers of these maps generated by Geological Survey of India can be accessed. This is how the scales can vary. The purpose of the maps may be chosen according to your requirements, and the area can be decided. So all these are possible using Geological Survey of India's Bhukosh website. Now there is another organization at the national level working on landslides. It is National Remote Sensing Center, a part of Indian Space Research Organization, who have been doing these studies using the satellite imageries, aerial photographs, and other geospatial technologies, in which they have also prepared the zonation maps for the country and also the different states. And you can see that they have provided some information based on these data which they have done using the maps and the seasonal data and the number of events recorded using the geospatial technologies in different states. So the 18 states which we had actually marked as those where the landslides have been happening are given in the column 1, and the information about the events on each year you can see are mentioned on there. Now, based on these events, the total number of landslides you can see in the northwestern Himalaya is about 19,096, covering an area of about 106 square kilometer. Now, that means they have a large size. Then the northeast Himalaya, it is about 19,645 landslides. But if you look into the area covered by these landslides, is just 30 square kilometer. So that indicates, that means there are larger number of landslides but smaller in size. So more widely dispersed but less covering area. Then the Western Ghats, it has 6,593 landslides covering about 23.49 square kilometer of the area. So that means number of landslides in the Western Ghats are again, they are actually larger than the northeastern Himalayas in terms of area, but less in terms of area compared to northwestern Himalayas. So that is what can be concluded from this information and data available from the mapping done by NRIC or information extracted by NRIC. NRIC has also worked along the definite road maps, routes, particularly they covered the pilgrimage routes in Uttarakhand and Himachal Pradesh, where they prepared the landslide zonation maps. And they had also developed certain mobile apps to collect data from the ground for the landslide inventory and also share their information with the masses and the concerned stakeholders. So you can see that they have an app at their web portal called Bhuvan. Bhuvan is that web portal where the NRIC has been sharing its images and satellite maps for the masses, and these you can use from that portal and may be made available. Not only they are mapping, they are also using this information for an early warning. So they have not only used the geospatial technologies from the satellites, even the unmanned aerial vehicles, the drones, have also been utilized to make studies of landslides or do carry out their mapping at the site on a larger scales. So this is how they have done the studies of the recent Uttarakhand disaster at Chamoli. Now the third organization which prepared landslide zonation maps based on the available data was Building Materials and Technology Promotion Council under the Ministry of Urban Affairs. They prepared these maps in 1:15 million scale. That means they were preparing it on the national level, and they did it with the support of concerned technical organizations. So this is one of those maps which was generated way back in 2001 by the BMTPC as part of their efforts to make different hazard map. They have not only just made maps or landslides, they prepared it for floods, they prepared it for Cyclones, they prepared it for earthquakes and multi-hazard. So vulnerability atlas, currently you can go to the website of BMTPC at bmtpc.org. I have just listed below the link, and you can see the distribution of the landslides that have been reported in India. At the time this map was prepared, there were data of about 9,883 landslides. Currently, as per information received from Geological Survey of India, more than 65,000 landslide data is available now. There are more than 65,000 landslides. However, I can see that there are many countries who have done even more intense mapping in terms of lakhs of landslides within very small areas reported by them. And while we were preparing a national guideline on management of landslides and avalanches, and even before that, I remember this map was even available during 1998 through one of the senior geologists from Geological Survey of India, who actually gave different colors based on the different degree of landslide hazards in different parts of the country. So you can see very high hazard, moderate hazard, low hazard, and very low hazard areas within our country prepared in the beginning. And now, after the national landslide susceptibility mapping has been undertaken, these priority areas were decided based on the frequency of the landslides and the area covered under the landslides. So you can see there is a red area which is priority 2. The green area is priority 1, which has been completed, and the yellow area is priority 3, which is under progress. So about 0.42 million square kilometer of our country's land area is affected by landslides of various degrees. And this landslide susceptibility mapping has been done by the Geological Survey of India, on 1:50,000 scale. Then besides the national maps, the state maps, there are regional maps also made available by different technical organizations within the country. You can see landslide susceptibility map of the whole state has been prepared by Wadia Institute of Himalayan Geology in 2022, where they have actually depicted very low, moderate, high, and very high landslide susceptibility zonations, where the different methodologies have been used to carry out these zonation mapping. So depending on the accuracy of these techniques, the landslides can be validated from these maps. Another map which was produced by NRSC for the same state, Uttarakhand state, but it was restricted primarily along the pilgrimage route, which I just mentioned before in 2001, and using their own technique and methodology for landslide hazard zonation. And this is also covers the Uttarakhand, the Kedarnath route, as well as the Badrinath route, the Yamunotri route, and the Gangotri route. And also the important townships of the hilly areas. You can see a map of Mussoorie area, where a lot old habitation exists since British periods or even before that. And these areas have been disturbed by human interventions, and landslides have been reported from there. And these different parts of this hill, they were mapped for landslide susceptibility zonation using a bivariate statistical method. And this copy of this map is available in the publications. Then Pauri Garhwal area, another part of Uttarakhand state, where the Garhwal University, they did some studies and prepared maps. So you can see all these publications, they have been actually either published in some journal, in some report, or in the form of atlases and the maps for the areas. And these are not just restricted to the nation, state, region, or the district, but also to specific project sites. For example, you can see TD Dam, which is one of the highest dams in the country, which is with the earth core rockfill dam, where the terrain zonation has been done for landslides along the reservoir area. So you can see the bluish area, which is water reservoir area, which is getting discharges from the Bhagirathi river as well as from the Telangana river. And adjoining all the slopes, they have been categorized into high hazard, low hazard, moderate hazard, very high hazard, and very low hazard. So high hazards, you can see the reddish tinges where most of the landslides are reported. Similar microzonation studies on even specific landslides have also been done. So we started from the nation to the state, region, to the routes, specific routes and specific projects. And then we have come down to the specific landslides. And these landslides have been studied in the very large scales of 1:500 to identify different pockets of the landslides moving with different velocities in different directions and identify the areas which do not move. So this is how the landslide zonation of a site-specific landslide is done within the country. Then other states I'm talking to you now are Himachal Pradesh, where Dalhousie Chamba Brahmpur route, Shimla Bilaspur Kullu Manali route, very much studies have been done, and even Shimla Rampur Sarhan Sumdo route, all these routes, the landslide zonation studies were done by the National Remote Sensing Center of ISRO during 2001 on a scale of 1:25,000. So this scale you can see is varying from 1:6 million, 1:15, or 1:2 million to 1:50,000, then 1:25,000, 1:10,000, 1:2,000, 1:1,000, 1:500. And even sometimes for the mitigation measure, the mapping has been done in 1:100 scale also for the project size. Similarly, other studies which have been done in Himachal Pradesh include the landslide hazard zonation studies of Dharamshala area, where Dharamshala is actually embedded in between the two major thrusts, the main boundary thrust and the main central thrust, is very much prone to landslides, not just because of the heavy precipitation which it receives annually. Annual precipitation of Dharamshala area is almost more than about 5,000 millimeter annually on an average. It's just next to Chirapunji, Mosinram, where maximum rainfall in the country happens, and also the seismic activities occur. So both the rain-induced landslides, the water-induced landslides, as well as the earthquake-induced landslides or triggered landslides are in existence into such areas, besides the anthropogenically triggered landslides that we can observe. Then the Kashmir area, again, zonation mapping has been done along the highway and a number of landslides were reported, and these area routes were classified into severe, very high, moderate, low, very low. These were the categories which were done. and the scale of mapping was 1:125,000. So you can see that the degree of the maps and the scales are quite variable. Then Darjeeling area, close in the West Bengal, which has been suffering landslide susceptibility, has also been mapped. And the technique which was utilized for zonation mapping of the landslide was knowledge-driven statistical models. So if one is interested to know where do the landslides happen, what are the areas where we can expect landslides, so such maps can be utilized. Seismic landslide hazard map again is available for the Karnataka state as well, using the GIS technique, which has been published in journal. Then Nilgiris again have been mapped. Nilgiris in fact were one of the first areas where the landslide zonation studies were done by the Geological Survey of India, and maps were available. And then Kottayam district of Kerala, 2016 map is available. Now many universities and centers for earth science studies, the Kerala University, they have been working, and you can see they are classifying either into 5 categories of landslide susceptibility, from very low, low, moderate, high, and very high, or into 3 categories of low, moderate, and high. So that is depending on their approach and the technique being used by them. In Tamil Nadu, Nilgiri Hills, another publication showing the map into different zones using the other different techniques. So this map is basically eastern part of the Nilgiris. Then Komoli Ghats area, again landslide macro zonation studies were done by Shanmugwali, Alumai, Sarnathan, and Vaidyanathanji. So there are a number of researchers who have been doing studies and also working on the different degrees of landslide hazards for preparation of landslide susceptibility zonation map. Now, finally, I come to Odisha. Look at the Odisha. Then we find mostly the disaster in terms of the cyclone impacts, which is very, very high and severe, and followed by floods, earthquakes, and then landslides. So there are limited number of landslides which have been reported in a post-cyclonic conditions when heavy precipitation took place. And this precipitation actually been noticed mostly in the southern part of the Odisha, close to Bay of Bengal, particularly the Gajapati district has reported some landslides in Odisha, which has been demarcated by the Odisha State Disaster Management Authority. And these are some of the reports from the media which covered the landslides which happened in Odisha state during 2014, 2018, 2019, and 2021. The reasons behind these landslides in Gajapati area may be because of the changing climatic conditions, the unscientific or unsystematic or unplanned interventions in the hill slope areas or the slopey lands, and also the heavy precipitation brought by the cyclones in the post-disaster situations, which is actually rising the pore water pressures of the slope masses and resulting into landslides. And also there are possibilities that the huge discharge in the rivers can cause the toe erosion of the slopes and landslides. So there can be several reasons for the landslides which need to be studied. However, it is there, and one of the important landslides was that happened with the cyclone Titli, where about 12 persons were feared dead. So these are some of the informations that I would like to share with all of you. And I hope this information would help you understand the distribution of landslides across our country in different states, in different regions, and within the state of Odisha. So in order to now enhance the human capacities or resilience and reduce the risk, NIDM, which is the nodal institution, a statutory body under Disaster Management Act 2005, has established a World Center of Excellence on landslide disaster reduction with the support from International Consortium on Landslides under the International Program on Landslides by the Global Promotion Council of IPL, UNDRR, and ICL. So the trainings are conducted on the subject area face-to-face as well as online, and the concerned stakeholders and officials are made to understand the consequences, the distribution, the causes, the factors, the dimensions, and the controls of landslides. They are expected to carry out the tabletop exercises to develop their own skills and their own confidence in managing the no landslide incidences and their impacts. This was one of those training programs which was conducted. The previous slide also from Visakhapatnam area, and also they are made conversant with the geoinformatics and geospatial technologies using the computer sets for the landslide studies, and then they are taken to the field sites to explain them these field situations and make them familiar and conversant with those situations which can result into landslides, and cautions to be taken and care to be taken for development in those areas. Besides these national level programs, state level programs, we have also international programs where we had actually Indo-Japanese cooperation between Government of India and Japan. We exchanged the MOUs with the major institutions and Ministry of Land, Infrastructure, Transport and Tourism from Japan and our own institute, and conducted workshops both in Japan and India to enhance our human capacities and to learn from the Japanese. And the International Consortium on Landslide also made a declaration during the Sendai conference, the third World Conference on Disaster Risk Reduction, where the Sendai framework for DRR was declared. The Kyoto landslide commitment was also done at that time from 14th to 18th of March 2015. And the person who is speaking is actually Professor Kyoji Sase from the Tokyo, Japan. He is a professor there in Japan who's worked a lot on landslides. Then the programs are also conducted by inviting experts from the specialized institutions across other countries. We have, you can see, an expert from ITC Netherlands. We had an expert from CNRI, RPI. We had experts from German Geological Survey of India and our own experts from India. So all these are there. And in order to enhance these human capacities, we developed a self-study program on landslides. There are 10 self-study courses in which one of the program is focusing on landslide risk reduction and resilience. The efforts were well appreciated, and an award was given as one of the best e-governance projects. During COVID-19 also, we went with webinars and online training programs involving national and international experts into these subject areas, and also talking about the ethical perspectives of this. And also we document the major events which have occurred you can see that one of the events which happened during 2013 from 8th to 12th of October, the Phylline cyclone has actually been covered at our institution to discuss what went wrong, what went right, and what can be learned from these events, so that in future we have better strategies and developments with reduced risk and enhanced resilience. Similarly, from Uttarakhand disaster, we are conducting annual conferences and landslides. This is one of the photos from the national conference. We had the international conference also, you can see, involving the highest levels of the dignitaries, the ministries, the land departments, the disaster management authorities, and expert organizations. And we are making publications from them, and even a training module you can see on comprehensive landslide risk management has been published by National Institute of Disaster Management. This is the older one, where the Hindi version was also published, and the directory of the resource persons, organizations, and the publications made within India or for India by any expert has also been listed down in these articles, which you can find from our website. Then how to construct and develop in landslide prone slope areas is also published by NIDM activity books, and more information you can get from these websites of Government of India who work on landslides. No one can do all these things alone. We need to build partnerships, because I cannot be master of all subjects. So therefore, I will join hands with others, collaborate and network with others, and build partnerships with them to meet the challenges of landslides. This stone I saw on a crossroad in Japan while I was working in cooperation with them, and I couldn't identify. When I asked my Japanese friend, they said, Surya, you move this stone in any direction, it will quickly regain its position. And Japan is prone to earthquakes, avalanches, tsunami, landslides, floods. So we teach our society to behave or become like this stone, as symbol of social resilience against disaster situations, to gain the situation or the condition just before the disasters occur as quickly as possible, like this stone. So I think we need some kind of such social symbols of resilience in our country also, where we have wide variety of the disasters that we face. Our dream of the national policies to make the country free, with zero casualty and resilient India. We have the Coalition for Disaster Resilient Infrastructure, and we work as a team. As we said, team means together each achieve more. And I tell you that I'm sharing one of my favorite photos. When I was working in the field for a landslide rehabilitation in a forested land area, I was supported not only by the government, administration, line departments, everyone, or the local communities and the NGOs, but also this wildlife. The monkey came with its baby on the car, which was provided to me by the local temple's priest son for as a gesture of goodwill for the field work. So the sport is given by all, and wild hostile life also becomes hospitable and affectionate to you if you do good to them through disaster management. And disaster management does provide you an opportunity to do good and have good. So this is what I wanted to conclude with my presentation. Thank you very much. I will just close this here. Now, if you have any questions, you can ask me. So friends, it's still, I think we have 15-20 minutes. So if you want to ask any questions related to this, I restricted my presentation only to the maps And the landslide issues, I have not covered the mitigation aspects. I have not covered the landslide monitoring aspects. I have not covered the landslide early warning because that was not part of the theme given to me. So if you are interested to learn even more, you can always go to our training module on comprehensive landslides risk management, where we have provided all these information as well. Or you can access our self-study program and learn from those videos, which are audio visuals.
So,
If there are any questions,
audience, please, they may put forth if there is any question from any side. So,
see, I'm not teaching you landslides. I'm just sharing information about landslides. So learning about landslides would surely require more lectures and more focus with the variety of the lectures that you would need. All right.
okay, thank you, sir, for your excellent presentation on the topic in which you are a master. So, the participants have been immensely benefited by your vast experience and knowledge. So, once again, on behalf of the participants as well as the organizing committee, I would extend heartiest thanks to you for sparing your valuable time to be made to make yourself available for this program. So, thanking you once again, I would like to close the session 3, and after that we will have our assignment session. So all the participants have to answer 10 questions for the presentations that has been made today, and the assignment link will remain open up to 10 p.m. in today night. So thank you all. Now we shall close this session 3, and all are requested to go to the link of the assignment. Thank you all.
Thank you, dear, for inviting me and also patiently listening. I hope this presentation will give some insight about the landslide generation mapping within the country and across the states. And I wish we will have more time and more discussions on it. And once again, thank you very much and wish you all the best in your endeavors.
Thank you so much, sir.
So I'll leave then if it is okay.
Okay, sir. You can.
Okay then. Thank you. See you. Wish you all safe, healthy, and good quality life on an equitable, justifiable, and right-based manner, with good fraternity amongst all of us. I'm happy to share this with all concerned faculty members. Thank you.
Okay.
Thank you, sir.
Thank you, Jayanti.